All right, so again, welcome to the session. We are we're going to talk about data. We know that data science is based on data. So without data, even Sherlock Holmes says, I can't find out any deduction without data. So without data, we can't do. And if we are doing anything without data, then we are just guessing things. We are not making a informed decision. For a manager to even get a clue, even get some prediction value is very valuable. So data helps him do that. So let's just understand what kinds of data do we have with us now in the 21st century. So data is just a collection of facts, right? And data can be numbers or it can be text. I want to go for a drive is also data, and data can be in the form of images, data can be in the form of videos. So example is YouTube, Facebook have lots of videos and pictures. So all that is data. And then data can be small and structured, like tabular rows and columns that we saw just now. And then it could be unstructured, which is huge and unstructured, like these videos of Facebook and text and images. All these are unstructured, and we convert them into structured data and then feed it to our algorithm, right? So earlier we know that we had a floppy disk that had only kilobytes. Now we have tetrabytes of data. We have to devise new numbers to know that is the amount of data that we have. So what do we do with this huge data? We use this data to answer business question, and this is where data science comes in, right? So to understand data science, we have to first understand data, because based on our data only, we find out what algorithm to use, what situation to apply, and how to interpret the results, and what patterns to seek in the data. So if we talk about structured data is tabulated data, which has rows and columns. And so like we said, it could be, rows are also called variables. They are also called, columns are also called variables. They're also called dimensions. They're also called features. And rows are also called cases. They're also called instances. So this is a case. This is a case about India. And this is about a case about a person whose features are Indian, 38 years of age, 48,000 salary, and he has not purchased the product. So these are features. These are 4 features of one instance or one person or one case, right? So a row is a case and columns are features or variables or dimensions, like we saw. So again, data, like we mentioned, not necessarily that they are numbers. They can be digits, they can be pictures, but whenever there are pictures, we need to convert them into numbers, because computer understands only numbers. So if we have an analog figure image, we will convert it into a digital image, and then digital image will have pixel values, and we'll use that pixel values to process it through our algorithm. So if this is a figure of 8 and this is a figure of 8, we will convert it into pixels and then use all these values. So you can see this values. So here in these pixels, a value of 0, if there is a value near 0, so if you see this value as 0, then 0 means dark, right? And 256 means white. So this, if you see the value here is 254, so it's almost near white. So if the pixel has a value of 256, then it is 255, then it is white, and if it is value of 0, then it is black. So depending on the number of the value in the pixel between 0 and 255, it is able to get a shade. So if it's not a colored image, then it will have these values. If it has a colored image, then it will have the value of red, green, and blue. So for each value of red, green, and blue, there will be a value between 0 to 255. So red will have the value from 0 to 255, which will tell us the shade of red. Green will have a value of 0 to 255, which will tell us the shade of green, and similarly for blue. So we will have 3. So this will become a 3-dimensional vector with these values 3 times. For each pixel will have 3 values if it is a colored picture. And that is how we convert our unstructured data or our images or pixels into structured data, and then you feed it to our algorithms, right? The same way we do it for text. The same way we do it for emails and videos. So because we know that video is just a collection of pictures. So in the same way, we do it for videos, which adds another dimension, a time dimension to pictures. So we have a picture, if it is colored, we will have a 3-dimensional, we will have RGB, and we will have the pixel values for all the 3 RGBs. And then if it is a video, we will have pixels for each photo, so over a period of time, and all that will come under one array or one data set with more than 3 dimensions, for around 4 or 5 dimensions, and that would be my video data set. So again, when we are learning in data sets during the development of a machine learning project, the developers completely rely on data sets, right? So machine learning means it's learning from past data, and using past data is trying to make predictions for the future. So in building machine learning applications, data sets are divided into 2 parts. One is the training data set, one is the test data set. We don't look at the test data set when we are making the model. We don't look at it. We'll only look at it when we are testing. So this part is cut off. It could be 20% or 30% of the data set. Depends on how big is this data set. If this training data set is vast, if it's already millions of records, then we might just leave 10% data here. So we split it into any ratio, 20, 90, 80, 20, 70, 30, any ratio, and then we use one set for the training, the larger set into training. Again, in training also, training data set also we divide into training set and validation set. What do I mean by validation? I make the model on the training data set and then test the model on the validation data set. And if some change has to be made in the model, if some tuning has to be done in the model, if some parameter has to be changed in the model to make it a more accurate model, then I am testing all that and doing all that using the validation data set. I have not shown the test data set to the model ever until I have made the model. When the final model is made, then the final test of the model is done using the test data set, and final accuracy of the model is figured out. Now, now this accuracy would be, why do I not use the test data set? Because I assume that this kind of data will be available for validating, for using in future. So I'm just generalizing my model, that my model is not just working on the training data set, but it's also working on the test data set, which is data which it has never seen, right? So any kind of data that is going to come for the predictive model, it will be able to predict. That is what I'm going to test with the test data set. Because the new data that is going to come, the new question that I'm going to ask after the model is ready for production, after the model has been ready and I want to predict that data, the model does not know. So before doing that, I'm testing it with my test data set. Then again, there's so many kinds of data. So it could be relational data that records documents or text, or it could be sequential data, like, transactions in a bank. There is a sequence to it, or it could be, the sequence could also be of, say, stock market data, share market data, right? So there's a sequential data. Or it could be video, which is, we discussed sequence of images. Then it could be temporal data, time series data. Again, time series data would be stock market data. The changes in the disease or the blood pressure. So we are measuring it over a period of time. Anything that is measured over a period of time, and say rainfall over, say, 12 months or over 12 years or over a century. All that is sequential data. There is sequence, there is a time series to it. So that's time series data. Then genetic sequence data. Again, our genes has a lot of data. We know that thousands of millions of records are stored in our genes. So when we find out that data and put that data into document, we say it is genetic sequence data. Then spatial data, maps, in which space matters. Image is also a spatial data. In image also, the place matters. My nose the distance between my nose and my ear determines the structure of my face. If you change the position of my nose, then my face's image will get distorted. So there is, spatial means space, right? Spatial means space. So maps and image data have spatial features. You cannot change the space between two. So for example, I'll give you an example here. If we have this data set, now whether I pick up row number 1 or I pick up row number 14 or I pick up row number 20 and model, it does not matter, because this is not spatial data, right? Or for example, in our bank data, this person aged 30 has no relationship with this person aged 42. So if I pick up 5 people from this, or randomly pick up some rows, 80% of the rows randomly, and do that and make my model, it does not matter, the model will be fine. But if I take up this data, and I change the position of this 256 to here, then the shape of the 8 will change. There will be a white here. So I cannot pick up some part of the data set and then do. I cannot pick up 80% of this data set and do. I will have to maintain the spatial information, because this is black, and only when this is black and this is white and this is white and this is black, that the figure 8 is formed. So spatial data. So in the same way, for maps, we have spatial data, because the distance between New York and Washington has to be same. The distance between Gurgaon and Delhi has to be. I cannot, when I'm processing the data, I cannot take away that information of the data and put it in any row. I have to maintain the information about the distance between Gurgaon and Delhi. Only then the map makes sense. Otherwise the map gets distorted. Now again, data could be, other ways of looking at it is big data. Or it could be structured, unstructured, and semi-structured data. It could be time-stamp data for time series data. It could be machine data. What do I mean machine data? Machine data is the digital exhaust created by the system, technologies, and infrastructure powering modern businesses. So, you have a face recognition in your company, or you have a punch-in where the employees come in the morning and they punch in. So machine generates who came at what time. Or all the videos, recordings that are happening when you go to a mall, or you go to all that is computer generated. Or say I'm wearing my Apple Watch or my Fitbit watch, so when I'm moving, it is recording my blood pressure, my heart rate, my number of steps I have walked. All that is machine data. Or maybe in a factory, a machine is running, so the kind of production it has done, how much production it has done, what movements it's doing, all the robotic data, robots that are working, all the data about their movements, about their production, about their use of fuel, use of electricity, all that is machine generated data. So that is called machine data. Spatio-temporal data is spatial-temporal data, describes both location and time, right? So locations, for example, the rainfall happened in Cherrapunji in 2010. Right, so that data will have both. If I delete one row or one column, one aspect of that data, then the data will lose value. So that is spatio-temporal data. It has both. It becomes relevant only when I have both the location and the time of the data with me, right? And it can show us how phenomena in a physical location change over time. So Cherrapunji would have rainfall in 2010. Cherrapunji will have 2011, and maybe California had 2010 and 2011. So at those two physical places, the measure of rainfall at a particular time is what I'm going to have in both spatio-temporal data. Then open data. What is open data? It's freely available to anyone in terms of its use. Right, that would be open data. And what is dark data? Dark data is digital information that is not being used and lies dormant in some form. So there's data in your organization, but it's not used by anyone, right? It exists, but nobody knows about it, and nobody's using it. So that becomes dark data. Open data again would be where data is available for people to work on, and anyone can use it. In fact, we will be looking at a lot of data sources. So I had bought some data sources today. So these are some data sources that, so we have Kaggle data sets, we have UCI machine learning repository data that's available to us for learning purposes. Then we have data from AWS, which is Amazon, and we have data from Google data search. engines. Then we have data from Microsoft Research Open. All these sites are giving us data sets so that we can learn. So there is computer science data set, there is social science data set, there's physics data sets, there's information data sets. Then GitHub is another platform which provides me data. Then there is visual data available of pictures. So we'll look at it. We'll look at more of these data sets as we go forward. So coming back to types of data, there is real-time data, which means that one of the most explosive trends in analytics is the ability to stream and act around real-time data. So some people argue that this term itself is something of a misnomer, that data can only travel as fast as the speed of communication, which isn't faster than time itself. So logically, even real-time data is slightly behind the actual time of data. But what we mean here is that real-time data would be, for example, you are using your credit card. Now, as soon as you use your credit card, the bank is testing whether they should allow you to use your credit card or not, and they're running an algorithm behind. So if they suspect that it's a fraud, they will block your credit card and they will not let you use the credit card. So for example, you always use your credit card in Gurgaon, but so you are using it, say, in Panipat, and you're using it in a jewelry shop. You've not ever bought any jewelry and you're using it, so they might give you a call that there is a transaction happening on your credit card of this amount. Now, how will they know that there should be a call and that there should be an alert to you and to them? Because they're running a algorithm, real-time algorithm at the back end, right? So that's real-time data. Or any other feature in which real-time analysis is getting done would be real-time data. Then genomics data, DNA data, we already discussed. Genomics data involves analyzing the DNA of patients to identify new drugs and improve care with personalized treatment. Then operational data, companies have big data, they have application logs and metrics, they have event data, they have information from microservices applications and third parties. And the question is, how can they turn this data into business insights that decision makers and non-technical teams can use, in addition to data scientists and IT specialists. So these are other forms of data. Would be high dimensional data. We now understand what is a dimension. The features are the dimensions. The variables in the data set are the dimensions. So high dimensional data is a term being popularized in relation to facial recognition technologies, right? So due to the massively complex number of contours on a human face, we need new expressions of data describing all nuances and individualities that exist across our facial physiogenomics. So unverified or outdated data, right? So garbage in, garbage out, we understand it very well. So data should not be outdated. If I am looking at the share price of, say, Reliance, and I want to predict what will be the share price tomorrow, I cannot use the data of 1998. That is outdated. I'll have to use recent data. Maybe now I can't even use data before Corona, because there is an event, an unprecedented event that has happened. So if I use data before Corona, I'll have to be careful, and I'll have to do some normalization on that data before I use it. So data can be outdated, right? And it is unverified. Unverified means we don't know where it is coming from. Whenever we're using data, we try to know where it is coming from, whether it is authentic or not, whether it's going to solve my business question or not, right? Then translytic data, an amalgamation of transaction and analyze. Translytic data is argued to enable on-demand real-time processing and reporting with new metrics not previously available at the point of action. Translytic data would also be, like I mentioned, that when I'm doing a transaction on my credit card, then they find out metric, they calculate certain metrics for me, and then they take action, whether to give me a call, whether to pass my transaction, or whether to block me. So all these are examples of types of data available. Then we have, these are mostly examples of where data came from. Now that we have the data, how does my data look like, right? So data types, right? So data can be categorical or it could be numerical, which means that category could be in the form of qualitative data or non-numeric data. Categorical would be qualitative or non-numeric. So for example, gender, city, nation, all these are categories. So that becomes categorical data. So in our example here, this column would be the categorical data column, right? And these two would be the numerical data column. This is numbers. This is categories, whether the category is male or whether the category is female, right? So it could be categorical or it could be numerical. In numerical, it could be discrete or it could be continuous. And discrete means that the counting process, for example, the number of cars manufactured or the number of students coming to the class. There cannot be 2.5 students. There cannot be 2.5 cars manufactured, right? So that's discrete. That's 1, 2, 3, 4, 5. All right. And then continuous would be, say, the height and the weight. So they're continuous. It could be any height, any weight. It could be 60.2578 kgs or 60.2875 kgs. Any number. It's on the number line, it is continuous. So that becomes a numeric continuous data. So we stop here. We will be discussing more about types of data in our next class.